Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. AIPs Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a truncated cylinder which has been cut by multiple cutting planes over here. So now we can see that here we have got a right cylinder having the diameter of the base equal to 40 millimeter, and this cylinder is resting onto the horizontal plane on its base, and it is being cut by multiple cutting planes over here. The height of the cylinder happens to be 75 millimeter. So with this information, we are required to obtain the development of the lateral surfaces of this truncated cylinder over here. So now let us proceed to evaluate the orthographic projections of the cylinder. As the cylinder, it is going to rest onto the horizontal plane on its base, which is measuring 40 millimeter diameter over here. So now into the top view projections, we are going to obtain the circular projection of the cylinder onto the horizontal plane, which will be drawn below the XY reference line. Now the diameter of the circular projection we have taken as 40 millimeter, and we have divided the circular top view projection of the cylinder into 12 equal segments over here, such that the included angle of each of these sectors will be equal to 30 degree over here. So the 12 points corresponding to the top face we have marked into the top view projections outside the circular projection over here, while the 12 points corresponding to the base of the cylinder we have marked with red color on the inner side of the circular projection of the cylinder into the top view projections over here. And the access points O and O1, they have been marked into the top view projections. So point O, it corresponds to the access point of the top face of the cylinder, while point O1 represents the access point at the base of this particular cylinder. Now we know that the height of the cylinder happens to be 75 millimeter. So now using the projections from the 12 points of the top face and the 12 points of the bottom face, now we can obtain the front view projections corresponding to this untruncated cylinder over here. So the 12 points corresponding to the top face, they have been appropriately marked in the front view projections over here. Similarly, the 12 points corresponding to the base of the right cylinder, they have been marked appropriately onto the XY reference line into the front view projections over here. So now we are going to obtain the access points, that is O dash happens to be the access point corresponding to the top face of the cylinder, whereas O1 dash, it happens to be the access point corresponding to the base of the cylinder. So let us now mark the locations of the different cutting planes over here. So this is cutting plane number 1, which is inclined. So we have marked a distance of 40 millimeter from the top. So from this point onto the vertical generator 1 dash and 1 dash, we are going to join the top center point over here in order to obtain the orientation of the first cutting plane over here. Then the second portion of this cutting plane, it is moving into this direction, that is from the center of the top face and moving into the right side vertical generator 771 dash at a distance of 40 millimeter from the top face over here. Then we have also located the orientation of the semicircular cutting plane having radius is equal to 20 millimeter, and this semicircular cutting plane, it is going to cut the cylinder at the base of this cylinder over here. So now we can see this semicircular cylinder has intersected with all the 12 vertical generators of this right cylinder over here. Similarly, these two AIPs, they have also intersected with all the vertical generators of this right cylinder over here. So let us first of all obtain the development of the untruncated cylinder to begin with. So now we are going to make use of parallel line development method in order to obtain the development of lateral surface of this cylinder over here. Now we can see from the top face we have drawn a horizontal projector line. From the base of this cylinder again we have drawn a horizontal projector line, so that the height of the cylinder we have obtained over here. So this is the true length of the height of the cylinder which we have been able to obtain between these two horizontal projector lines. Now corresponding to the 12 segments of the circular projection over here, now we need to measure distance between each one of these sectors over here. So we need to measure the distance between the circumference points of each one of these 12 sectors over here. So the distance between 1 and 2 will be same as distance between 2 and 3. And similarly, all these sectors, they will be available with us at the same distances over here. So these 12 sectors we have obtained over here, and we have started the development from the point 1. So starting from point 1, we have got points 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1. So these are all the 12 points corresponding to the 12 sectors which are available at the top face. Similarly, corresponding to the bottom face, all the 12 points onto the circumference, they have been appropriately developed into the plane surface over here. So now we have been able to obtain the development of the untruncated or the uncut cylinder over here. So let us evaluate the points of intersection of this semicircular cutting plane with the vertical generators of this particular right cylinder. So these are the 12 points of intersection corresponding to the semicircular cutting plane over here. So let us obtain the development of the truncated cylinder by virtue of intersection of the base portion of this right cylinder by this semicircular cutting plane over here. So point A dash, it happens to lie onto the vertical generator 1 dash and 1 1 dash, and point G dash, it happens to lie again onto the base onto vertical generator 7 dash and 7 1 dash over here. So if we draw horizontal projectors through these 2 points A dash and G dash into the development surface view, then we will observe that the intersection of this horizontal projector with the vertical projector 1 1 1, it will provide us with the location of the point A in the development surface view, and the intersection of the horizontal projector drawn through the point G dash with vertical projector 7 7 1 over here, it will provide us with the location of the point G into the developed surface view over here. So next point of intersections we have got, they happen to be B dash, L dash, F dash and H dash over here. So we know that B dash and L dash, these are 2 points of intersection of the semicircular cutting plane with the vertical generators 2 dash, 2 1 dash and 12 dash, 12 1 dash over here. Now if we draw horizontal projector through B dash and L dash, we can see point B will be obtained onto the vertical generator 2 2 1, and point L will be obtained onto the vertical generator 12 12 1 over here. Similarly, another couple of points of intersections F dash and H dash, they are going to lie onto the vertical generators 6 dash, 6 1 dash and 8 dash, 8 1 dash over here. So point F dash will lie on 6 dash, 6 1 dash, point H dash will lie on 8 dash, 8 1 dash. Let us evaluate the intersection of the horizontal projector line drawn through the points F dash and H dash with vertical projectors 6 6 1 and 8 8 1 over here. So this way points F and H, they have been obtained onto the vertical projectors 6 6 1 and 8, 8, 1 over here. So the 4 points of intersection corresponding to the semicircular cutting plane, they have been appropriately located into the developed surface area over here. So the next 4 points of intersection, they happen to be C dash, A dash, E dash and I dash over here. So we know that point C dash, it is going to lie onto the vertical generator 3 dash and 3 1 dash. Whereas K dash point, it is going to lie onto the vertical generator 11 dash and 11 1 dash over here. So once we draw horizontal projector through the points C dash and K dash, let us evaluate the intersection of this horizontal projector line with 3 3 1 and 11 11 1. So the intersection of this horizontal projector with 3 3 1 will provide us with the location of point C. The intersection of this horizontal projector line with the vertical projector through 11 11 1 will provide us with the location of the point K over here. So another 2 points of intersections, they are E dash and I dash, obtained on 5 dash, 5 1 dash and 9 dash, 9 1 dash over here. So now point E dash happens to lie on 5 dash, 5 1 dash. Point I dash happens to lie on 9 dash, 9 1 dash over here. So now once we draw horizontal projector line through the points E dash and I dash. So let us evaluate the intersection of this horizontal line with 5 5 1 and 9 9 1. So this intersection with 5 5 1 will locate point E into the developed surface area. This intersection with the vertical projector 9 9 1 will provide us with the location of the point I in the developed surface area over here. And this point of intersection is D dash and J dash. So D dash point happens to lie onto the vertical projector 4 dash and 4 1 dash over here. Whereas J dash point, it happens to lie onto the vertical projector 10 dash and 10 1 dash. So once we draw the horizontal projector through the points D dash and J dash, now we obtain the intersection of this horizontal projector with 4 4 1 and 10 10 1 over here. So this intersection with 4 4 1 will provide us with the location of the point D. The intersection of this horizontal projector line with vertical projector 10 10 1 will provide us with the location of the point J into the developed surface area. So all the 12 points of intersection we have been able to obtain corresponding to intersection of the base portion of this right cylinder by the semicircular cutting plane having radius is equal to 20 millimeter. So the development of the truncated base has been appropriately obtained over here. So now let us obtain the development corresponding to these two inclined cutting planes over here. So now these two cutting planes, again, they are going to intersect with all the 12 vertical generators of this right cylinder over here. So we can check point A1 dash, it is lying on the vertical generator 1 dash 1 1 dash, and point G1 dash, it happens to lie onto the vertical generator 7 7 1 dash. So if we draw horizontal projector through A1 dash and G1 dash over here, the intersection of this horizontal generator with 1 1 1 will provide us with the location of the point A1, and the intersection of this horizontal line with 7 7 1, it will provide us with the location of the point G1 over here. So all of these 12 points now we are going to mark with blue color over here so as to distinguish between black point of intersections corresponding to the semicircular curve and the blue points of intersection corresponding to the auxiliary inclined planes which are inclined with respect to the horizontal plane over here. Now the next 4 points of intersection, they happen to be B1 dash, L1 dash, F1 dash and H1 dash. So we know that B1 dash and L1 dash points, they are going to lie onto the vertical generators 2 dash 2 1 dash and 12 dash 12 1 dash respectively. So now once we draw horizontal projector line through these 2 points of intersections B1 dash and L1 dash, now let us evaluate the intersection of this horizontal projection line with vertical generator 2, 2, 1 and 12, 12, 1 over here. So this point of intersection with 2, 2, 1 will provide us with the location of point B1. This intersection of the horizontal projector line with the vertical generator emerging through the points 12, 12, 1. It will provide us with the location of the point L1 in the developed surface area over here. Similarly, corresponding to these 2 points, F1 dash and H1 dash. So these 2 points, F1 dash and H1 dash, they happen to lie onto the vertical generators 6 dash, 61 dash and 8 dash, 81 dash. So once we draw horizontal projector through F1 dash and H1 dash, let us evaluate the intersection of this horizontal generator with 661 and 881. So this intersection of the horizontal generator with 661, it will provide us with the location of the point F1. The intersection of this horizontal generator with the vertical generator, that is 881 over here, it will provide us with the location of the point H1 in the developed surface view over here. Next 4 points of intersection, they happen to be C1 dash, K1 dash, E1 dash and I1 dash. So C1 dash happens to lie on 3 dash, 31 dash. K1 dash happens to lie on 11 dash and 11, 1 dash over here. So once we draw the horizontal projector line through C1 dash and K1 dash, let us evaluate its intersection with the vertical generators 3, 3, 1 and 11, 11, 1 over here. So the point of intersection obtained on 3, 3, 1 will be called as C1, whereas the point of intersection obtained on the vertical generator 11, 11, 1 will be labeled as K1 point over here. Now another 2 points we have got corresponding to the same horizontal projection line, that is E1 dash and I1 dash. So E1 dash point happens to lie onto the vertical generator 5 dash and 5, 1 dash over here. And I1 dash point, it happens to lie onto the vertical generator 9 dash, 9, 1 dash. So once we draw the horizontal projector through E1 dash and I1 dash, let us evaluate the intersection of this horizontal line with vertical generators 5, 5, 1 and 9, 9, 1 over here. So the intersection of this horizontal generator with the vertical generator 5, 5, 1, it will provide us with the location of the point E1, and the intersection of this horizontal generator with the vertical generator of the cylinder 9, 9, 1, it will provide us with the location of the point I1 over here. Now the next points of intersection we have got, they happen to be D1 dash and J1 dash. They will be lying at the top center location over here. So D1 dash point lies at the top face of the cylinder corresponding to the vertical generator 4 dash, 4, 1 dash, whereas J1 dash point also lies at the top face of the cylinder corresponding to the intersection of the AIPs with the vertical generator 10 dash, 10, 1 dash over here. So if we draw a horizontal projector line through these 2 points which are lying at the top face, that is D1 dash and J1 dash points over here. So now the intersection of this horizontal line with 4, 4 dash, it will provide us with the location of the point D1 at the top surface of this cylinder over here. Similarly, the intersection of this horizontal projector line with the vertical generator 10, 10, 1 over here, it provides us with the location of the point J1 in the developed surface view. All the 12 points, they have been appropriately marked in the development of the lateral surfaces of the truncated cylinder over here. So now we can check the top face has been sectioned by the auxiliary inclined planes over here. Similarly, all the base portion points, they have also been sectioned by this semicircular cutting plane over here. And this portion of the edges, that is A1 and A, so they have not been sectioned by the cutting plane. So this portion has not been sectioned by the cutting plane. So we can join A1 and A and A1 and A over here. So this way we have discussed about the intersection of a right cylinder by two auxiliary inclined planes and one semicircular cutting plane over here. So this is all for today. So through this discussion, I hope that you would have understood about the procedure. How do we proceed with the development of the lateral surface of the truncated cylinder, which has been cut by multiple cutting planes and the different orientations over there. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.